All right, guys, welcome to FRQ Type 3, Particle Motion Problems Notes. So this is a common type of FRQ question with some pretty predictable types of things to expect. So first of all, the thing about these, they're typically calculator active. It's possible for them to be non-calculator, but for the most part, this is the part of your AP test where they do allow you to use a calculator, so typically. Now, usually how these things are set up is they usually start by giving you a velocity function. It's possible they could start by giving you a position function. It's also possible that they could start by giving you an acceleration function, but a simple scan through your FRQ notebook there will show you that they're almost always velocity functions. So there's a lot of things they'll ask you to do after they've given you the velocity or whatnot. They may ask you to find the acceleration, which is usually about 1 to 2 points. The first point is, like usual, showing your work. The second point is getting the answer. A really popular question is finding when the object changes its direction. Once again, usually about 1 to 2 points. Finding the distance or the displacement. So you want to know the difference between those two things. Identifying a max or a min, and what that usually looks like is like saying when is the object farthest to the right, when is it farthest to the left, or when is it farthest away from the origin. But either way, the point is that we're looking for a max or a min, which, as you guys know, is a candidate's test, and those are almost always 2 to 3 points. Then a lot of times we're asked if it's speeding up or slowing down and finding its position, and in these notes we're going to go over an example of each one. So let's go ahead and begin here. A particle moves along the x-axis so that its velocity at time t is given by this function here. At t equals 0, the particle is at position x equals 1. All right, so let's go ahead and do this first one. All right, so the first thing they're asking us to do is to find the velocity of the particle at t equals 2. Now, this is honestly too simple of a question, but I'm just going to give it to you anyway, because I don't think I've ever seen an FRQ where they give you the velocity function and then just ask you to do something as simple as find the velocity. But I want you guys to be aware of how to do that, because a lot of times in the questions, that's something that is a sub-step, so you have to do it. In particular, it's relevant to Part C, and you'll see why when we get there. All right, so find the velocity of the particle at t equals 2. So how do you do that? Well, we have our velocity function, so it's as simple as just plugging 2 into the velocity function. I'm going to be using a graphing calculator for this because, as I said, they are typically calculator active questions. So let's go ahead and go to our calculator. I've already got it typed in, and just a few typing points to keep in mind is that this is a negative, not a minus, and the negative's down here. Don't confuse that with this button, which is a minus button. And then we have x plus 1. The rest of it's pretty straightforward on how you would type it in. There's not really much to the rest of it. So let's go ahead and we're going to get out of there now, because all I really want to do is I want to find what is v of 2. So I've got my v in there already under y1, so I'm going to push, let me get out of there, vars, scroll over to y1, I'm going to push 1, and then y1, and then in parentheses 2, and enter. And remember, in AP Calculus, we always round to the thousandths place. So my final answer is going to be negative 2.728. They don't usually provide units on these types of questions, I've noticed. They usually just kind of leave it blank. But if they do provide units, then make sure you know how to do the units for velocity and things like that. But I'm not addressing that in this video just because, like I said, they don't usually concern themselves with units on these particle motion questions. All right, now they're asking for the acceleration. All right, now I'm going to create a new variable. I'm going to call it A. And that's going to represent acceleration. But remember, anytime you create a new variable, you have to define it in terms of the variables they've already given you. Now, how do you find acceleration? Well, acceleration is the derivative of your velocity. So A is equal to v prime of t. So the problem, the readers of your AP test, they know what v is. They know what a derivative is. So now they know what your A is. They know that by A you mean the acceleration. And you think, well, isn't it obvious? I put an A. It's like, well, it may be obvious to you, but they can't grade you like that. So you have to define your variable. So we're going to say let A equal v prime of t, and I'm going to put A of 2. And by the way, you could have totally skipped this step and just started by, instead of doing A of 2, you could have just done v prime of 2. And that would also get you equal credit. It doesn't really matter. I'm just wanted to do that to reinforce for you guys the importance of defining things anytime you create a new variable. So I want to find the value of the derivative of my function at 2. So how do we do that? Well, by the way, the stuff that I'm writing on this slide, that would be your first point, setting it up. You have to show your work. On a calculator problem, it's tempting just to do it on the calculator, write down the answer, and move on. If you do that, you'll get 0 points, even if you have the right answer. You have to show them where you got that answer from. So let's go ahead and go to our calculator and show you how to do that. So how do we find the derivative? Well, you could try to find the derivative by hand, and in some cases you might have to. I wouldn't want to do it here because it's a product rule with a chain rule, which we've learned how to do before, but that can be a little tricky sometimes. But the cool thing is our calculator can do derivatives also. So let's go ahead and have our calculator help us. How do you do derivatives on the calculator? You push math, you push 8. We're going to say we're finding the derivative with respect to x. We're going to put our function that I'm finding the derivative of in there, which is my velocity function, which I've stored under y1. And then I'm going to plug in the number here that I want to find the derivative of v at, which is 2. And we have our answer. So my acceleration is 1.588. And we found up here that the velocity was negative 2.728. Let's keep that in mind. All right. Now the question is the particle speeding up or is it slowing down at that point? Well, anytime velocity and acceleration have the same sign, they're speeding up. But in this case, they don't. The velocity is negative and the acceleration is positive. So that would mean that it's slowing down. So we would say particle is slowing down at x equals 2. I'm sorry, it's not x. We've got to be careful with that. It's t equals 2. T equals 2. Since v of 2 and a of 2, and if you didn't use a, you could have put v prime of 2, have opposite signs, not opposite, opposite signs. At that point. Now, just so you guys know, typically, I've made this look like it's 3 questions, but it's really not. This is typically 1 question. The question is usually, is the particle speeding up or slowing down at t equals 2? So you need to know when you see that, oh, then I need to find the velocity and the acceleration at that point. And then I compare them, all right? So really on these types of problems, it could be anywhere from 2 to 3 points when you answer this, depending on how much information you didn't have already. Finding the velocity would count as 1, finding the acceleration would count as 1, and then your answer with your explanation down here could count as 1. So it just depends, but there you guys have it. All right, let's go ahead and move on to a second type of question here. Same problem up here at the top. All right, find each of the following. When is the particle moving left? When is the particle moving right? And when does the particle change direction? Now, all 3 of these questions can be answered in the following way. What you're going to do is you're going to find where the velocity equals 0, and you're going to do a number line test. And anytime the velocity is negative, that would mean that it's moving to the left. And anytime it's positive, that would mean that it's moving to the right. So, and then at wherever it switches, that's where it's changing direction, right? So how do we find where this function equals 0? So we're going to start by writing this. I want to find when does the velocity equal 0 so I can do my number line test. Okay, well now at this point, algebraically, you guys might be able to solve this. I can think of 2 answers right now just by looking at it. Set this equal to 0, set this equal to 0. You could actually probably solve that. But I want to show you once again using the calculator, because sometimes you're going to come across some equations where it's not going to be so easy to solve those equations right off the bat. So how do we find where it equals 0? Well, basically what we're going to do is we're going to look at the graph and find where it touches the x-axis. Anytime you want to find where a function equals 0, and you could do this in any number of circumstances, you're going to graph it and find where it touches the x-axis. But remember, that's only if it's a calculator active question. All right, so I'm going to graph it, and this happens a lot where your window looks funny because you were doing math before and you never really thought about changing it back. So we need to fix our window here. So I'm going to go ahead and push zoom, and then I'm just going to push 6 for standard. And what that does is it takes you to a standard 10 by 10 view. And now that I look at this, I realize that I probably should have put a limit on what interval we're looking at, because since this thing is oscillating, it goes off into infinity, so we'll never have a solid set of answers. So you guys won't have this problem on yours because I'm going to change it, but I'm going to add a little piece of information here for us. Find each of the following on the interval 0 to 5. I wanted these to have little equal signs under them. All right, so knowing that now, I want to come back to my calculator. Let's go to window. I don't want to go all the way out to 10 now. Let's go ahead and change my x values to just being from 0 to 5. That way we only look at the part that we really care about. Okay, so I want to know, when is this object moving to the left and when is it moving to the right? Well, it looks like it's crossing the x-axis in 1, 2, 3 spots. On the edge here, it looks like it's touching the x-axis, but it doesn't look like it actually dips below. Same thing over here. Now we could be a little bit careful and zoom in on those spots just to be sure that it's not just barely rising above the x-axis and coming back down. Same thing over here. And let's go ahead and just find the points though that we're certain about for now. So I'll find these 3. So we're going to go ahead and push second, and we're going to push calc. And the way you find where it touches the x-axis is you push number 2 for 0. And you pick a point to the left of the x-intercept that you're looking for, and to the right of the x-intercept you're looking for, and then you push enter again, and it tells you where that's at. Okay, so we have 2.507 is one of the places where it is touching the x-axis. Let's go ahead and find another one. So we're going to push second, calc again, number 2 again, and we're going to scroll to the left of the next point, enter, and then to the right of the next intercept, enter, and then enter again. And the next one is at 3.545. All right, and we're just going to keep doing that till we find them all. And the last one is 4.342. Okay, now just for the heck of it, I'll zoom in on this and see if maybe we're missing something. You could do that by adjusting your window, but that's a little bit tricky. I like to use the zoom button sometimes. It's a little bit new. So you can watch me do it, and if you want to try it, you can. I'm going to do zoom box. I like the zoom box function the best. What we do when you have zoom boxes is you're going to scroll your cursor all the way over to the place that you want to zoom in on. And what I want to do is I want to zoom in on this area right here and see if it's actually crossing the x-axis. So I'm going to get closer to that and push enter. And as soon as you do that, whatever direction you go, it starts tracing out a box around it. It doesn't look like it crosses to me. So I think we're safe to say that it's okay there. I won't be looking on the other one, but you could also go back to your original viewing window and look at the edge. But for now, I'm going to say it's safe to assume that this is the places, these are the only 3 places where it's crossing the x-axis. All right, so here we are. And by the way, I think maybe I can show you something kind of nifty here too if you want. You don't have to, this isn't a big deal, but you know, does it actually reach the x-axis here? Does it, what happens at x equals 5? Does it stay above? Is it below? Or is it right at 0? It's kind of hard to tell because sometimes we can't tell when it's this close. So what we could do is you could push second, calc, and then number 1 is value. So if you plug in an x value, it will tell you the y value at that point. So if I plug in 5, the y value is about 0.397, which means that it's slightly above the x-axis. So the answer is no, it doesn't actually touch the x-axis again over there. It was trying to get there, but it didn't quite make it by the time x equaled 5. Little detail, not a big deal. All right. But anyway, here's what we know now. We know that anytime the velocity is below the x-axis, which is on this entire interval here, and also on this interval here, anytime velocity is below the x-axis, that means it's negative, and when velocity is negative, that means the object is moving to the left if you're on a horizontal axis. And anytime it's above the x-axis, that would mean that it is positive, and therefore the particle is moving to the right. So on the following intervals, 2.507 up to 3.545, the velocity is positive. Therefore, well, actually, we could probably add the other spots too. Let me back up a little bit, because there's other places where it's above the x-axis, right? There's also the one over here. So that would be on the interval from 4.342 up to 5. Now, technically, if you wanted to, you could put a bracket here instead of a parenthesis, because these are where the velocity equals 0, and the velocity is not positive when it equals 0. But this one, we tested the endpoint, and actually it was positive. But just so you know, you would not lose points if you put a parenthesis there. They're not picky about that for some reason. So anyway, so on these two intervals, the velocity is greater than 0, and therefore the particle moves right on these intervals. All right. Likewise, we'll do the green side also. So that would be from 0 up to 2.507, and from 3.545 up to 4.342, the velocity is less than 0, and therefore the particle is moving left on those intervals. So now we know where it's moving left, we know where it's moving right, and therefore where is it changing its directions? Well, it's changing its directions at those points where it switches from green to red. So in other words, those 3 points that we found. So we could say the particle changes directions at 2.507. I should put t equals, actually. 3.545 and 4.342. All right? So there you guys have it. And on the AP exam, I have seen how this question is asked, and they usually just ask one of these three things. They're not going to ask all three of these because once you do one, you kind of know the others. So they're going to ask one of them. They may say, on what intervals is it moving left? On what intervals is it moving to the right? Or they'll ask, when is it changing directions? But they probably would not ask all three of them. All right, let's move on to example 3 here. On what intervals is the particle speeding up and slowing down? So to answer this question, what you need to do is you need to do a number line test where you compare velocity and where you compare acceleration. Now notice I just created a new variable, but not really, because I've already defined what A is back in example 1. So long as you've already defined it in one part of the FRQ, you don't have to define it ever again. So I already know what A means. It means acceleration. But what you want to do in these cases is you want to do a number line test where you compare the number lines for velocity and acceleration, and you see when do they have the same sign and when are they opposite. Because when they have the same sign, it's the particle speeding up, and when they have opposite signs, the particle slowing down. Now, we've already found all the places where velocity is positive and where it's negative, so I'm going to do that to my number line right now. So we found that on the interval from 0 to 2.507 it was negative, and then the next interval was positive, and it alternated until we got to 5, right? So now we need to do the same thing with acceleration. So what we need to do is we need to find when is the we need to graph the acceleration, right? And do the same exact thing. So how do you graph the acceleration? Well, remember, acceleration is the derivative of velocity, right? So how do we graph the derivative of velocity? Well, once again, you could just try to find the derivative by hand if you're more comfortable with that, but that's very time consuming. My advice to you would be to know how to do it on the calculator. So let's go ahead and take a look at our calculator and find how to graph velocity. I'm sorry, not velocity, but the derivative of our velocity. So I'm going to push y equals. And just so, I don't want to delete this function, I want to leave it there, but now you don't have to do this, but I think it makes things a little bit less confusing to look at. I'm going to make that line invisible. So I'm going to scroll over here to that little blinking line there. I'm going to push enter once, and that makes the line thicker. I don't want that. Then I push enter again, and that creates a shaded area. That's interesting. I'm not going to use that though. Another shaded area, this time it's shading below. This one has a ball with a line attached to it. I don't think I want that. But the one that has a ball on it, that just means whenever you graph it, you're going to see the ball bouncing around the screen, tracing out the graph, but it's not going to leave a line behind it. And that's the one I'm going to go with, because I don't want this to get in the way of what I want to see. I want to see the graph of the derivative. So now that I've got that, I'm going to scroll back over to the right and go down here. And I want to graph the derivative. Now, like I said, you can sometimes do it without having to do that, but I think it's going to be very confusing to look at if I try to graph that. So here we go. Let's find the graph of our derivative. So I'm going to go ahead and I'm going to push second calc derivative. Oh, actually, you know what? I take that back. Let's go back to the y equals page. You don't push second calc. You push math for the derivative, right? All right, second, you push math, and then you push 8 for the derivative. And we're going to type our function in. I want to find the derivative. The derivative of what? Of this function up here, y1. So I'm going to go to vars, scroll over to y vars, and push 1. So I'm finding the derivative of that function. Now here's the thing. A lot of times you put a number here because that's the point where you want to find the derivative at. But in this case, I want to graph a function of the derivative. So when you want to do that, you put an x there. And then we're going to go ahead and push graph. And you guys see that little ball there bouncing around? That's tracing out the velocity, which I don't really want to see right now, so I made it invisible. So we'll let it pass. And now it's going to graph the other function, which is the acceleration. Looks pretty similar, doesn't it? All right, so there's my acceleration. So I need to find these places, 1, 2, 3, and 4 spots where it's touching the x-axis. I'm not going to be writing them down on the screen, but you guys might want to be writing them down as we go. So here we go. Let's find them. I'll remind you one time, then I'm going to pause the video and just find the rest so you guys don't have to sit here and stare at me doing the same thing over and over again. So second, Calc 0. And notice how right now, look at my cursor, it's moving along that invisible line that I can't see. Do you guys remember how to switch functions? You push up or down and it will take you to the other function. So now I'm on the acceleration function. All right, so I'm going to go to the left, I'm going to go to the right, I'm going to push enter, and my first point is 1.873. All right, I'm going to pause the video here and then I'll find the rest and write them all down, and I'll show you what I got in a moment. All right, so now as I do this, we're going to want to make sure that our numbers line up well. So notice that when I put these numbers that we had for velocity here earlier, and I put a line directly underneath of those on this axis just so I know where those markers are at. So the first one that I found where the acceleration equals 0 is at 1.873, which would be to the left of this one. So I'm going to put that like right about here, 1.873. And I'm going to put a marker up here. And since I just split that interval up, I'm going to erase my negative up there. And I'm going to say, okay, well, velocity is negative on both of these intervals. Okay. And what I found by looking at the graph of my acceleration is my acceleration function was below the x-axis on that interval. So, on the interval from 0 to 1.873, my acceleration was negative. All right, and then after that, it was positive. Because it was above the x-axis. And it stayed that way all the way up until I got to the next place where it touched the x-axis, which is at 3.096. So this is 3.5, right? So 3.096 would be just a little bit, to the left of that. So I'm going to put 3.096 here. And like I said, the acceleration stayed positive until that point. And I'm going to transfer that up here. And in between those two, the velocity was positive here. All right. Now, after 3.096, the acceleration became negative again. It was below the x-axis. And it stayed negative until I got to about 3.976, which I would put right about here. And then I'm going to transfer this little dot right up here like so. And I'm going to squish my negative in there like so. All right. After that, it switched back to being positive again until we got to 4.697, which I'll put right here. And then after that, it was negative again. Transferring this 4.697 up here, the velocity stayed positive, though, all the way up until 5. So now we have all these places where we can see where acceleration and velocity were negative and positive. Now I'm just going to draw a straight line through each one of these important points that we've created. Places where the velocity equals 0 and places where the acceleration equals 0. And then all we have to do is compare their signs. So for instance, on this interval here, they're both negative. On here, they're both positive. And then here they're both negative, and here they're both positive. And so those are all intervals where it's speeding up. All right, so speeding up on those three intervals, since on those intervals B and A have the same sign. In the same way, we would say that the particle is slowing down on these intervals because on those intervals they have opposite signs. All right, and so in red over there I've got the intervals where it's slowing down and the reason, since that's where they're having opposite signs. So you want to write down your intervals and have your explanation. In retrospect, I might have picked a different function or interval. That way we don't end up having so many answers. That was a little overwhelming, but the point is the same. You're going to do a number line test for velocity. Then you're going to graph your acceleration and do a number line test for that as well. And then you just compare their signs where they're both positive and where they're both negative. And that's how you can find intervals where an object is speeding up or slowing down. All right, example 4 here. We want to find the distance and displacement of the particle on the interval. All right, so distance can be found. I'll label it. You don't have to do this on the AP test because they're not going to ask for both at the same time typically. They might, but distance is found by doing the integral of the absolute value of velocity on the interval that they're asking about. Displacement can be found by doing the same thing, but just without the absolute value. Okay. Now distance, I think you guys know what distance means. That just means how far an object has traveled over that time period. Displacement, though, tells you something a little bit different. It tells you how far the endpoint, or I'll say the ending position, is from the starting position. A little bit different. Now, if the object was always moving in one direction, then the distance and displacement will be equivalent. Maybe an opposite sign, but same value. But if the object is bouncing back and forth, which ours was, the distance and displacement will definitely not be the same. The distance will be much bigger than the displacement because every time it goes back and forth, the displacement kind of gets reset to where it was. But distance will just keep increasing and getting bigger and bigger and bigger. Okay, so that's what those two things are. Let's go ahead and punch them into our calculator and I'll write down the answers. And here's what I got by calculating those. So this means that the object traveled a total of 4.334 units. This one tells me that the object is negative 2.197 units to the left of its starting position. So that's distance and displacement. Let's go ahead and take a look at the next one. Find the particle's position at t equals 3. Okay, well, if you ever want to find a position, then the particle's position, and by the way, up here they've defined what the position function is. The position function is x. So it's safe to say x of 3 to represent the position of the particle when t equals 3 without having to define it. So the position of the particle at 3 is equal to its starting position. At t equals 0, it's 1. Now, it doesn't always have to be a starting position. By starting, we mean the time is 0. You have to go with whatever time value they give you. So if they give you t equals 1, then you'd put a 1 here. Plus the integral from that starting number, which is 0. Once again, if this is a different number, then this will be a different number, which I saw a few of you guys didn't quite get on some of the exams we've done. Remember, whatever time value they give here, it goes here and here. It doesn't always have to be 0. But anyway, so ending position is equal to starting position plus displacement. So end equals start plus displacement. Now we know the starting position, x of 0, is 1. So I'm going to put a 1 there. And from the last question, we also know the displacement was negative 2.197. And so if I just put those things together, I can find my position. Okay, and so that one's done. Let's move on to our last question. which is the maximum and minimum question. And as you guys know by now, we've done so many of these, I'm sure it's well drilled into your mind. This is a candidate's test question. Okay, so anytime they want to know a max or a min, well, at that point, you need to find or do the candidate's test. So, which my input is t, and basically if they're asking for the maximum distance away from the origin, you can tell how far it is away from the origin if you know its position. And so basically what I want to do here is I want to find the position of the particle, okay? And whichever one of these numbers is farthest away from the origin, which is 0, then that will be the maximum distance away from the origin, right? And so the interval we're looking at, we always do our starting time and our ending time, as well as any critical values in between. Now, what are the critical values? Well, let's see. Here's my position function. The position of the particle at any time t can be found by taking the starting position, which is 1, and adding to that the integral from the starting time, which is 0, up to whatever time you're interested in, which we'll just say is t in this case, and then v of t dt. In other words, the starting position plus displacement, right? Now, what are the critical values of this object's position? Well, the critical values are where the derivative equals 0. So what's the derivative? Well, if you take the derivative of 1, that goes away. And if you take the derivative of the integral function, this cancels out and this variable drops in, but it's the same variable, so you just end up with this. So the derivative of the position function is the velocity function, which hopefully we already know that. Now, I want to find, where does this thing equal 0? In other words, when does the velocity equal 0? Well, we've already done that. It's where it touches the x-axis. So let's go back to our calculator here, and I just want to refresh your minds. Let's see. So we're going to go to y equals. I don't need my acceleration function anymore, and just so my calculator can go a little faster, I'm going to clear that now. I just want my velocity function. But remember, I also made that line invisible. I'm going to go back and fix that now just by scrolling backwards and pushing enter until I see, that's a dotted line, until I see a nice solid line again, and then we're good to graph it. So let's graph it up again. So here's my velocity function. And we're just going to find all these places where it touches the x-axis, which we've already done. And a lot of times they design questions like this on the FRQ to help you save time, where you're going to use information you've already found previously to answer questions about current questions to save time. So 0 is equal to v of t at each of these 3 values, which are my critical values. I'm going to go ahead and put those in my table. And now what I want to do is I want to go ahead and plug those numbers in to my function, my position function, this guy right up here. Now, the good news is on a calculator, once you do 1, you can very quickly get all of them by just using a little operation on your calculator that brings back the last thing you typed. So let's do that. But before we begin, we already know what x of 0 is. X of 0 is 1. That's the starting position there. But let's go ahead and see if we can find all these other positions now. All right, so we're going to go back to our home screen. And basically what we're going to do is we're going to plug in each of these numbers to find this value. So for instance, x of 2.506. We're going to take our position function here, and we're going to be plugging in the 2.506 here. And that will tell us the position of the object at that point, and that's what we'll punch into our calculator. So let's do it. We have 1 plus math 9, 0 to 2.506. And it might have been wise if earlier I had stored these under alpha A so it's more precise, but it'll probably be fine if we just leave it as is for now. So there's our first position that we find after the starting one. And now we're going to find the others. Now finding the others is a lot simpler and quicker. All you do is you push second and then enter, and it brings back the entire function again. And all we need to do is backspace and replace these numbers with what we have in our next one. So my next one here is 3.545. Enter, and we've got our next point, which is now the next position, which is 0.391. Okay, and we're just going to keep doing that. So I'll pause the video here and I'll do the rest of them real quick. All right, and so there's my answers. Now, at this point, you have to pay attention to the question they're asking. They're asking, when is the particle farthest away from the origin? Okay, so in other words, we don't really care if the number is positive or negative. We just care about which one has the greatest absolute value. And that would be this one. That's the one that's farthest away from the origin. Okay, now if they asked another question, like let's say they asked, at what time is the particle farthest to the right? Well, that would be your starting position. That's the biggest positive number. So you have to pay attention to the question. Are they asking when is it farthest to the left? Are they asking when is it farthest to the right? Or are they asking just when is the number greatest away from the origin? So pay attention to those questions. You also have to pay attention to the question in, were they asking for the time or were they asking for the distance? So let's go back and look, because honestly I forgot. Because that does matter. Find the particle's maximum distance. So they're not asking for the time when that happens. Sometimes they do. If they're asking for the time, then you would say this. They're asking what is the particle's maximum distance. So the particle's max distance is the absolute value of negative 2.265. We don't care about whether it's positive or negative, we just care about its distance, which you could just leave it like that, or you could write the positive one. It's fine either way. But there you guys have it. So that's the end of particle questions. These are the most common and basic types of questions that you can expect to see. You'll see other things, probably like one or two different things on them as you're going, but for the most part, you'll see something like a couple of these. All right, hopefully that was helpful, and we'll see you guys for the next one.